Alrighty, so today we want to work on dynamic programming. Why? Because it is very important and highly related to AI, especially reinforcement learning, which is RL. All right, okay, I guess it's about the time. And because I guess we all know AI is everywhere, and the AI agent is going to be the future industry. There we go. Good. So therefore, let's get back to where we start programming algorithm related here, which is to some question here. I guess, Alex, we both understand this is the most naive solution. It's two loops traversal and solve the problem perfectly. But it's basically too slow, and we want to enhance the algorithm. Therefore, it could make our overall algorithm better and faster. All right. Okay. There we go. So firstly, we have to use something called dynamic programming here, right? So I'm going to simply just remove all of these, okay, naive code here. All right. And we do not use a vector. Instead, we're using a unordered, okay, unordered map. All right. A map has two parameters. The first one is a key, the second one is a value. All right. It's like a dictionary. So for instance, you search a dictionary, a certain vocabulary such as splendid, right? Splendid is the key, and the description is basically the value, right? Good. Okay. And then we use the memo to define its name here. And then we have to use a loop, right? Because we need to traverse the data. So this is no negotiable. So we have to use it. All right, there we go. And then we have int n equals nums period size, right? Okay. This is from 0 to all the way to the end. All right, and then so since we're making decisions, so we just put the big picture first, right? If and else. There we go. And then we also need to create a difference, right? So this is a difference equals a target subject um nums of I, right? Okay. Why? It is because target is supposed to equals or simply is f I and j equals a of I plus a of j, right? Oh, j is the lowercase. A of I and a plus a of j. Any more mathematics um, perspective, I guess we can use these equals x plus y. All right, something like that. Okay, there we go. So for instance, x is a diff and y is a difference, right? Okay, and then we make decisions here. So firstly, memo find and find what? Find diff. If there's no diff, that simply means it's all the way go through the end, right? Okay. So that simply means, all right, memo does not track or record or save, right? Save the diff yet, right? Okay. So which means yet means about to do it, right? So that simply means about to do it. So therefore, memo period square bracket we want to save the current position into the key, right? So this is index, and this is basically the current, whatever the value, which is can be 2, 4, or 7, anything else, right? And else simply means what? Else simply means memo has already saved the data, right? So therefore, we simply do what? We simply just return the results here. So firstly, we put I, and then it's a memo, and we check the value by the key in the past, right? There we go. And then right here, all we need to do is just return something. Okay. All right. So overall, this is dynamic programming right here. So if you implement this code, let's see the efficiencies here. So that would be 58%. All right. But sometimes based on, yeah, it's supposed to be the fastest way. All right. There we go. Yeah. Good. So this is dynamic programming here. It's very important. Um, so I recommend you to go over all of these contents, this lecture note, later. All right, pretty good. Uh, and also go over the chapter 7, dynamic programming. All right, so it's always to find optimal solution. It's highly related to AI. All right, okay, very important, very important. So right now I'm going to show you a little bit on the whiteboard. All right, okay, there we go. Just give me a sec. All right. Hello, Alice. You can see the whiteboard, right?
Yeah.
Okay, good. Never mind. I have another camera, so I'll be sending you another video as well later. All right, Alex. So basically, it's going to be dynamic pro programming here. All right. It's highly related to AI and the RL here. So I guess we all know AI is very important, and that is going to be the future trend. So there, no, it's actually present trend, right? So we have to implement AI everywhere, basically. Okay, good. So let's see if you can see this better. Yeah, there we go. Good. Uh, the question here, right? So the two sums here, right? So giving 2, 7, let's say um what was the 15, all right, and then 12, right? Okay. So we need to find two numbers here. And then the sum is going to be the targeted number. So for instance, target is, let's say, 9. I guess we have to add a 9 here, right? Okay. So apparently the result is 2 and a 7, right? If the result is 2 and a 7, so the very easiest way or the most naive way is traversal it. So therefore, we have 2 and a 7 here. But is there any way we can make it a little bit easier? All right. It's basically using the DP programming, which is the dynamic programming. Why? It is because we can simply do what? So for instance, this is a diff and this is the current data, right? And then this is the index basically, right? And this is the current value. I'll just use A of I here, right? Okay. So we define a different, right? We define the diff equals t minus x. All right. And then in the first round, all right, we know, all right, t minus I or t minus x is going to be 9 is actually 9 minus what? 9 minus 2, and that is a 7, right? So therefore, we put a 7 right here, right? Makes sense. We put a 7 over here. Okay. And then do what? We put a 7 over here, and then we also track is the index. The index currently is 0, right? And so basically, right, and then we need to traverse the memo, right? Memo period find all the way. Well, actually, currently there's no such stuff, right? So because this is a empty. This is basically an empty chart, no nothing here, and no nothing here. So if there's no data right here, that simply means the find if if all the way to the end. There's no such data, right? If there's no such data, what does that mean? That simply means we need to, that simply means what? That simply means we have to add it here, right? Okay, because we have a method. Do you agree? So the method is basically if what? If and the memo of none of I is I. Well, actually, this is a diff, right? Diff. So therefore, this is the diff, right? So we put 0 here, and we also save. This is 0 here. We also save the current one, which is what? Which is 2 here, right? And then this is the first iteration. First iteration, it has 2 and a 0 here. Second iteration, the pointer moves to here, which is 7. All right, 7. All right, and then we do this different again. So therefore, we have diff equals 9 minus 7, which is 2, right? Therefore, we need to go through this chart, and then actually we see there is a 2 here, right? Okay, we see there is a 2. Therefore, it is actually a pair. So this is the way that dynamic programming works, right? Because it saw is a value here. So actually, this one is 2. Well, hold on for a second. This is 7. This is 7. My bad. And this is 2 here, right? And then it saw it. So this basically is a 7, and then we have 2 here. Then there's a match. There's a match, right? So that's why eventually um, it will return something like I and the nums of diff, right? Okay. Because the diff right here, we have 2 here and 7, then it is going to be the final solutions of this dynamic program. All right. Okay. Currently, Alex, do you have any questions in terms of this demonstration?
Um, I don't really get it.
Currently, let's see. All right. So first of all, you just pretend you are AI. Pretend you are a robot, right? So um, therefore you can think in a robotic perspective. All right. All right. So I guess probably read through the content a little bit, and then I'll give you probably 5 minutes to go over this a little bit, and then let's see. Let's see if you can understand this a bit better. All right, sounds good. Yes, you can actually see everything right here, right? Yeah. All right, Alex, I want you to share your screen. Therefore, I'll be knowing what you're doing here. All right.
Okay. Wait, so do I just share of like the doc?
Well, at least to share something I can see what you're doing. Yep.
Okay. I'll just share the doc then.
Okay. All right, Alex, I'm going to demonstrate this again. So now do you have a little better understanding of this?
Uh, uh, yeah, I guess so.
A little bit, right? Okay.
Yeah, but it like doesn't explain fully like what it is.
Yeah. Okay, so I'm going to demonstrate this a little bit. I mean, this is a very difficult one, so it takes a time to really understand. So if you, I mean, take your time to understand. I mean, yeah, just all right. So I'm going to also record this a little bit. So therefore, later on, you can. Oh, it's okay. It's recording it. All right. So dynamic programming, right? Okay. But it's important as. All right. Can you see? You can see that, right? Here we go. It is dynamic programming. All right. Programming is highly related to AI, the AI, and the RL. Uh, why? It can optimize solutions. It can optimize the algorithm. Um, Therefore, it can enhance the working efficiency rate. So this is the optimize algorithm. All right. So one very important example is two-sum question in lead code. That is the very basic dynamic programming questions. Um, and we all know the very basic traversal is two loops, right? But it's too slow, and we want something faster to optimize the solution. And then that's why we want to use dynamic programming here, right? Okay. So dynamic programming is basically, well, better enhance the working efficiency, right? Okay, but we also need to know the mechanism of that. So basically, it requires a hash map, right? So this is a hash map, right? A hash map, a hash, a hash map, or is unordered map, MAP map. All right. So whenever you see map or a dictionary, it is a table, like Excel chart. Okay. This is one example here. Okay. And what you can actually do right here is basically you can have the DIF different and the current index and the current real value here, AI here, right? So, and I suppose we have the sample data, which is what? Which is we have 2, 7, 12, and 15, right? Okay. And we want the target to be 9. And apparently it's going to be 0 and 1, right? But however, what if we want something different, right? We want something like probably maybe let's say 7 plus 12 is going to be 19, right? So there's any way to get 19? I don't think so. So therefore, 19 is going to be the new target. So the ideal result is 1 and 2, right? We have 1 and 2 as a result here. But how would you get this? So firstly, you have to make a formulas here, right? A formula is basically a D equals T minus A of I, right? Okay. The T and in the first round, right? In the first round, apparently D, all right, D equals what? So D equals 19 minus 2, right? In the first round, D0 equals 19 minus 2, and that is a 17. All right. Okay. And you pass the 17 inside because the the memorization or the dictionary or the unordered map doesn't see it yet. So therefore, you actually save this one inside, right? So therefore, you pass this down. So you have because it is what? It is this is zero, and they also pass the number of diff here, which is what? Which is 17, right? Which is 17. Okay. You pass the diff. And you also have the original one, which is 2, right? And in the second round, you have d I'll just stand here, right? Then you have D1 equals 19 minus 7. That gives you 12, right? Okay. So 12, do you see 12 here? You know 12 here, right? Then you put 12 here. And you track its location. And you also track the current data, which is 7, right? Good. And then in the third round, D2 equals what? D2 equals 19 minus, we have 12. Then you have 7, right? 7, all right? By looking through it, right? It actually, you see, you have already seen 7 right here, right? So therefore, this is a match. This is a match, and you do not do anything to this map, right? It stops right here. And if it stops right here, that simply means all you need to do just to get the current data, right? So that's why it returns I and M of D, right? Okay. So M of D, this is M of D, right? You have 12. So therefore, you have 1 and 2, right? Okay. Therefore, it returns the result immediately like that. So this is dynamic programming. It's using a map. And you probably want to say, we create extra space. Well, indeed, yes, we did. But this is very small. Current human technology can handle these extra space very easily. So no worry about it. Okay. All right. So right here, I would say math, very important, and computer science. There we go. Good. Um, as you can see, so dynamic programming here, right, is faster and better, and especially because of the data structure itself, the mechanism, the overall traversal is O1, so it's a constant time complexity. So that's why most of the times we want to use these. It also works a very important role as the AI, right? So suppose you don't want the algorithm to go through all the data by loop, right? What if we can save the data in a server or something, right? So then using the dictionary to just traverse it. And this is also part of the latest AI models, right? Okay. All right, Alex, now does this makes more sense to you?
Yeah.
All right, there we go. That's good. All right. So, a little bit for
I can't hear you.
all right, there we go. I guess looks pretty good. Uh, so now I want you to go over these. I want you to personally, manually solve this problem by yourself. All right. Okay, you get the big picture, right? I guess. Okay. So now please share our screen. Good.
Okay. Which one?
Google Docs. Or
Ah,
yes.
okay.
Hey Alex, do you want me to show you how to do that again on the whiteboard?
Sure.
Sure.
You recorded though?
Yeah, I recorded already.
Okay. And can you put it on the doc then?
Oh yeah, sure. But do you want me to do it alive again? No.
Sure.
Sure? Okay. I'll just show you another different, every time's the inspiration can be different, so therefore, I guess. Okay, I guess. So therefore you have two angles actually. You can watch from this angle or another camera's angle. All right. All right. Dynamic programming. All right. So Alex, I'm going to demonstrate dynamic programming implementation, sample cases, and why it is so important again. All right. Okay, there we go. So first of all, there we go. Here we are. It is a dynamic programming. All right. So this is the algorithm. So this is the algorithm, right? And dynamic programming is highly related to AI and LRL, all right? Reinforcement learning and artificial intelligence. So, for instance, um, suppose we need to traverse something, right? But the data is too big, too large, and how would we possibly enhance our working efficiency? We can basically, well, record or track the data at a data structure such as map, unordered map or dictionary. Therefore, we can use O1 time complexity to go through it. So the key point is optimization is how we want to make our program algorithm work faster and more effective, right? So basically effective, better, save energy, right? Okay, there we go. So first of all, it is going to be using a map, right? This is a map, right, or a table. So literally speaking, the dynamic programming, the most data structure is going to be a map, all right, a map or a dictionary, an unordered map, or whatever this stuff, or hash map, right? Okay, there we go. What is a hash map? What is a dictionary? It's basically a table. It is basically a table. The table allows you to record and track data. So for instance, we can create a diff and the current index and the real value here, right? Okay. One good example question is to sum in lead code. So for instance, we have 2, 7, 19, 12, and a 15, right? So target number is 19. And we want to find two numbers. We want to find two numbers, which is sum is the target number. So the naive way is two loops traversal, right? Okay. But now what we can do is we can create a formula. It's basically a formula. The formula is I'll stand right here. The formula is basically D equals T minus A of I here, right? Okay. So DI, so AI here. T is a constant. T is a constant. It's a target. So therefore, we just keep it as a constant, right? Okay. Therefore, in the first round, right? So what do we get? So apparently what? Apparently, um, D0, right? So this is D0. D0 equals 19 minus 2, which is what? 17, right? 17 is not in the chart, so we put 17 here. We also put the I here, right? So this is basically the key right here. We put 0 here, and we also have the actual data here, which is 2 here. And in second round, D1 equals 19 minus 7, that is a 12, all right? And apparently, there's no such value here, right? So we put the difference, which is this one right here, and we also put one here, and then the actual data is 7. In the third round, D2, right? Now this is a different story because in the D2, we have something here because the D2 equals 19 minus what? Minus um, uh, 15, 19. Well, I guess this is a bad example here. I'll just cut it off. I just cut it off, right? So yes, this is actually 12. So we're using 12, all right? Okay. So 12 minus 12, and we have 7. All right. See, 7 is here, right? And it saw or it has already in the system here. So that simply means there must be another pair, right? So therefore, the algorithm stops right here. So therefore, we don't have to go through all the data uh, all the way, right? Then it stops right here. It's like traverse and using the memory. It's a bit like human perspective, right? It's like, okay, I know the answer, but I don't know where to find the answer, right? So I keep in mind the answer in my heart. Then I look through something. It's like shopping, right? I want to buy a football, right? But I don't know where to buy. So therefore, I go to a shopping mall and I found the football. Well, because I know what I want, right? And then I get it, right? So it's something like that. It's like it's dynamic programming is like a little bit like using human perspective to solve the real world problem here, right? There we go. Okay. Hello, Alex. Do you have any questions in terms of these?
Uh, no, I get it now. Yeah.
You get it? All right. That's good. All right. So, okay. As you can see, so one round is about, this is a 9 minutes, right? This is 9 minutes. That simply means, right, study can be, it's time consuming. You have to practice a lot. Therefore, eventually you can master it, right? That's good. All right, now I want you to keep sharing your screen and work on the current stuff. All right. Okay.
Okay.
All right, Alex, keep sharing your screen.
Okay.